Hello everyone, I'm Ritu Saran, a research assistant at the National Museum Institute. I'm working towards the development and reorganization of the conservation laboratory and galleries at the National Museum. Before moving forward with this session, I would like to thank the team of Avijna Museum for creating such a platform and giving this opportunity to me. In this session, I will talk about the various imaging techniques that can be used for the purpose of examination of paintings and other artifacts. Let's start with the session. So the first and foremost question that would come to your mind is, why and how do we assess the condition of our tangible cultural heritage? There are numerous ways to assess the condition of our objects. Basically, assessing the condition of an object is an essential tool for conservators. A condition assessment will serve several functions, such as it will provide a recall of the current state of the condition. It will help in determining the nature of deterioration and its distribution pattern. It will also provide the basis for designing intervention treatment, further diagnostic investigations, and for monitoring condition in the future. Condition assessments may be undertaken at the beginning, during, or after the conservation intervention is made. In order to stop the ongoing loss, we need to understand the cause by investigating and recording the condition of the object. To do so, imaging is the most widely used documentation tool. It can be used to provide qualitative as well as quantitative data and allows us to look at the paintings, objects, and buildings in new ways. In short, imaging techniques are the methods of recording topographic information, that is the surface details. These imaging techniques can be broadly divided into two categories, basic and advanced. In basic category, we have normal light imaging, raking light imaging, macro and micro imaging. While in the advanced stage, we have multispectrum imaging, which includes visible reflectance, infrared reflectance, UV reflectance, and luminescence. For the purpose of demonstration, I have taken the case of a wall painting belonging to the Nagaur fort. These images were taken during a training program at the fort. This is the context image of the wall on which we will see how these techniques work. This is the area of the wall selected for carrying out condition assessment exercise. The following equipments are required for basic imaging: a DSLR camera, tripod stand, batteries, transmitters, flashes and receivers, and a handheld microscope like Danolite. Transmitters and receivers are required for the simultaneous functioning of flashes with the camera. The normal light image is taken when the light source, that is the flash, is kept at an angle of 90 degrees from the object, while the raking light image is taken when the light source is kept at an angle less than 45 degrees from the object. The direction of light source is a very important consideration in photography. A more diffuse light coming from 45 degrees produces better colors and texture representation than a light source is 90 degrees from the object, which can wash out colors and produce a flatter image. As you can see in these two images, the normal light image looks more flatter, while the raking light image gives more texture and shows us the ongoing deterioration of the paint layer. On the boundary of the painting, a layer of surface accumulation can be seen, which is more prominent in the raking light image, and that can be a case of salt efflorescence. This is another set of images showing the efficacy of raking light. In the raking light image, we can see a plaster joint. The upper half of the plaster joint looks more stable as compared to the lower half. The lower half looks more powdery as compared to the upper half, which may be a case of previous intervention. While in the normal light image, nothing much can be figured out. This one is clearly a case of previous intervention. In the normal light image, it can be seen that some repairing work has been done on the border of the painting, which gets more prominent in the macro image, in which we can see the difference in stroke of the original material and the material added later on, and also there is difference in the floral pattern drawn on the later edition. Now coming towards the use of handheld microscope like dynamite, we can see a pattern of cracks in the paint layer in the microscopic image, which would not be possible with the detailed image or the macroscopic image. Only microscopic images have the ability to show such texture. With the help of such information, we will be able to come up with the right conservation strategy. In advanced imaging techniques, visible, infrared, and ultraviolet radiations are used for the examination of objects. These techniques have been used to map the distribution of materials on objects in museums and galleries, and are also sometimes used to characterize these materials. Imaging methods can be subdivided into two main categories: reflectance and luminescence. Reflectance occurs when a portion of the light striking a surface is reflected back, while luminescence occurs when some materials which when exposed to radiations shows fluorescence. The following equipments are required for advanced imaging: a camera, tripod stand, batteries, transmitters, flashes, receivers, filters, torches, and safety glasses. Filters are required to block the visible, infrared, and ultraviolet radiation when required. These are to be placed on the camera and flashes. And safety glasses are required while working with ultraviolet radiation. This setup is a representation of how the system of reflectance and luminescence imaging works. Here, the flashes are used for incident radiation while the camera captures the outgoing radiation. Filters are applied on the flashes as well as on the camera. Now let's have a look at the visible reflectance, infrared reflectance, UV reflectance, and UV luminescence imaging techniques. In visible reflectance imaging, a UV filter is used on the flash, which allows the visible and infrared radiation to fall on the painting. The painting absorbs and reflects back a portion of infrared and visible light. An IR filter is used on the camera, which allows the visible light to be captured by the camera. Thus we get a visible reflectance image. In infrared reflectance imaging, a UV filter is used on the flash, which allows the visible and infrared radiation to pass through and fall on the painting, while in the camera, a visible light filter is used which blocks the visible light and allows the infrared radiation to reach the camera. Thus the camera captures an infrared reflected image. In ultraviolet reflected imaging, two filters are applied on the flash as well as on the camera, both to block the visible and infrared radiation and only allowed to pass the ultraviolet radiation. So, ultraviolet radiation is allowed to fall on the painting and a portion is absorbed and rest is reflected back, which passes through the filter and reaches the camera, and thus the camera captures an ultraviolet reflected image. In ultraviolet luminescence imaging, two filters are applied on the flash, one to block the visible light and other one to block the infrared radiation, only allowing UV radiation to pass through it. Thus the painting is incidented with ultraviolet radiation. If there is any material on the painting which is UV sensitive, it will absorb a portion of the UV radiation and the rest of the UV radiation will be reflected back. The portion of the UV radiations which is absorbed by the material in the painting is converted by the material into visible spectrum. Thus, a portion of UV light is converted into visible light. On the camera, a UV filter is applied, thus only allowing visible light to pass through it. So when this portion visible light reaches the camera produces an ultraviolet luminescence image. The following inference can be made from these imaging techniques. In infrared reflected image, more prominent outlines are visible as compared to the visible reflected image as a result of the IR photography, which is used to detect the underdrawings. The underdrawings are usually made of carbon black, which has a property to absorb the infrared radiation. Thus, the infrared reflected image shows more prominent outlines. Another inference that can be made is in the case of UV reflected light image, in which some dark patches are observed on the face of the figurine, which were not observed in the case of the visible reflected light image. In case of ultraviolet luminescence image, the plaster joint is clearly evident. The left side of the plaster joint is darker as compared to the right side, and also there is difference in the fluorescence of the figurine's face on the left and right side of the plaster. Brownish hues are also observed. Along with the cracks, scratches can be seen in the ultraviolet luminescence image. Due to later additions, or you can say previous interventions, differential deterioration pattern is seen in the ultraviolet luminescence image. The following are the outcomes of using these imaging techniques for the examination of paintings. They are non-invasive in nature, that is non-destructive, they do not harm the painting. They provide us with the topographic information about the painting. They help us in characterization of the original material and technique. They help us in knowing if there is any previous intervention made to the painting. And also they help us in illustrating the nature and distribution of the deterioration pattern. Thank you for your time and attention. I hope you liked the session.